All right, guys, it's me. I'm not sure why I'm wearing headphones. I don't think I need them. I'm not doing anything with sound, but whatever. I think some people are not used to not seeing me without headphones. It's me. It's Original Gamer Steve Bistro. We're back for another chapter in programming in BASIC, and we're going to jump into chapter 28, and this chapter is dealing with sorting. And so we're now going to learn how to use the Cocoa to do some comparative operations here, and we're going to start to use the greater and less than signs to see if something is bigger than this or smaller than this, and use that to actually sort. And so in the examples that the book is going to give us, we're going to be sorting things alphabetically, which is still a cool thing to understand how to do. And I'm going to be honest with you, I don't fully follow their logic because I didn't write their logic, but I will go through and read all their explanations. The book is pretty good about explaining itself, and hopefully that will make sense to both of us. And as much as sorting alphabetically, sorting text alphabetically is good, another thing that I'm going to want to implement in a video game is the ability to sort high scores. So you can have your leaderboards, right? Your top 10 scores, and sort your scores and show the top score as score number 1, and then the second best score, score number 2, all the way down. You know how that goes, right? So I had actually on my own figured out how to do this, 1.5 million years ago. Of course, I don't remember exactly what I did, but luckily I've got a friend. That friend's name is L. Curtis Boylan, Canada. So he gave me some sample code to show me how to sort numbers. And so I took his code and I used it and tweaked it just a little bit, or not really tweaked it. He kind of gave me an engine, so I had to fill in the engine. And then I also modified it to do both ascending and descending sorts. And so we'll look at all those, and we'll look at how to sort numbers, which will also become important as well. So we're in chapter 28. The title is sorting. Obviously, the topic of this chapter is sorting. And it says that any file clerk knows it's easier to find information that's sorted alphabetically. Type this program and run it until you're convinced the computer can alphabetize. And so this is our first little demo program. Of course, now I've typed in everything and I've saved them all. So I believe this first program is going to be 28-1. And so we're going to run it. And I think this one just compares two words. So type in, 2 words. It should be 2, TWO. Type in 2 words. So if I type in, for example, apples and oranges, it will say apples comes before oranges. So A is less than O. Alphabetically, numerically, etc. So if I said something like bananas and apples, it's now going to say bananas comes after apples. And so it's going to compare these 2 words and decide which one is greater than the other one, and which one do I display. So what does that look like? It looks very similar to how it looks on the book, because that's where I typed it from. But it says insert input 2 words. Let me fix that real quick. Type 2 words. And I think this was 28-1. I'm being real anal retentive, saving a stupid program that's only going to be used once. But hey, if you're going to do anything, try to do it right. All right, so the code says, take forever to save. It says input type 2 words, and it's inputting A string and B string. And then we've got 3 lines of logic here. And actually, we should try option number 3. So line 20 says, if A string is less than B string, then print A string comes before B strings, meaning if it's a lower value, then it comes first. If it says, if A string is greater than B string, then print that A string comes after B string. And then there's even a comparative here that says if A string equals B string, then print both words are the same. So let's try that right now. So for my first word, if I type in Bravo, and then my second word is alpha, it's going to say Bravo comes after alpha because it's greater, right? Now if I typed in alpha as my first word and alpha as my second word, hey, both words are the same because they are. So Simple logic comparing A string and B string a couple of different ways. If it's less than, then it's lower, it's smaller, it comes first. If it's greater than, then it's bigger, it comes after. And if they're the same, then they're the same. So that's our first demonstration, and I think that makes pretty much sense, right? So what it's saying here is with strings, the greater than and less than and equal signs have a new meaning. They tell which of the two strings comes before the other in alphabetical sequence. So if it's less than, it precedes. Less than equals combined says it's less or the same. Greater than is higher. Greater than equals means it's greater than or the same, and then equals means the same. So you can actually combine the greater or less than with the equals to give us two options, right? So it says, since the computer can alphabetize, then it's easy to write a sorting program. Type and run this program, which sorts 5 words. And so I'm pretty sure I made that one program 28-2. So we're going to load that one in right now. 28-2. And let's load it, and then let's look at it. So the program is pretty small. It will dim a string for a total of 5 options. It is then going to count from the number 1 to 5 for I equals 1 to 5. As you're going through there, it's going to say type a word. It's going to input, type a word. It's going to capture that input into A strings I. So we'll have A string 1, A string 2, A string 3, all the way through the 5 times. Now this whole looping logic here is what the book came up with. I don't completely follow it, but they do explain it as we go through. So just play along for a moment here. But it does start off by assigning a counter saying x equals 0 on line 50. Line 60 then increments x automatically. So in this case here, when we first run it, x went from 0 to 1. Line 70 says if you've done this more than 5 times, then just do an infinite loop here and stop, and this is where the program is going to end. If you're not greater than 5 and you haven't maxed out, then we're going to continue our logic. We're then going to say, well, if x is 1 and our A string 1 equals z or double z, then we're going to jump to line 60 where we're going to increment x again. If that's not the case, then we're going to start a loop. We're going to count from 1 to 5, and we're going to say if A string y is less than A string x, then x equals y. Continue to go through the whole loop and then say, all right, now we're going to print a particular string. We're going to say the string equals ZZ. We're going to go back to 50, which turns x to 0 again and starts an incremental counter. So somehow it's incrementing and doing some sorting and comparing, going back and incrementing and doing some sorting and comparing. And within this, even though I don't fully follow it, it's going to sort 5 things. So let's just try it for grins and giggles. So type in a word. So I'm going to type in reverse stuff. So I'm going to type in zebra, Romeo, Tango, Sierra, and Foxtrot. Okay, and now what it's done is it has actually sorted them in alphabetical order. So I actually typed them in almost descending, or literally in descending alphabetical order, and then it sorted them in ascending. So I've got my F comes before R comes before S comes before T comes before Z. So when comparing strings, it's looking at the alphabetical values and then seeing which letters are higher or lower than the other ones and doing the sort. So this is what the program's doing. Like I say, I kind of get it, but I don't fully get it because I didn't write this. I'm just taking it from the book, but the book will keep us going through, and then it does get to a page where it does try to explain everything. And there's another enhancement to this where they actually do visualize it, which I like. I'm big on visualizing. So then it asks us to make some changes. And so on the next page, it says make the following changes, and I'm pretty sure I did that already. So those changes should be on, well, first we're going to go to, so that was 28-2, I think. Let's try 28-3 and let's see what we end up with, because that one ends up like with line 520 or something like that. Yes. So we're going to run the program. Again, it's going to ask us for 5 words. And it's asking us to put in a specific set of names based on the book. Here in the book, it's asking us to enter the names Michael, Travis, Dylan, Alexa, and Susan. So we'll go ahead and do that. We're going to type in Michael. I got to click on the right damn thing here. Michael. We're going to type in Travis. We're going to type in Dylan. We're going to type in Alexia, and Susan. Maybe I have Amazon on the brain. And now we're actually going to watch it go through its sorting. It's figuring out what the first word is, and then it marked it off the list. Now it's going to figure out what the second word is, mark that off the list as ZZ, thinking that's going to be the highest one. Then it's figuring these things all out alphabetically, and then it's going through it. So, and we've put in some things to slow this down so we can actually see it thinking. And then boom, now it's got to the point where it has done it. So this little program here is visualizing the thing. So if I just make up 5 new names and I type in zebra, and then I type in watermelon, and then I type in something else like yak, and then I type in something else like queen, and I type in something else like sugar. So these are like all kind of some descending things. And so now it's trying to figure out what's the lowest letter in here. Okay, well, queen, that's my first one. So I marked that off of my list. Now I'm going through, what's my next one? Now we got sugar. What's next? Okay, watermelon. Okay, is zebra next? No. Okay, how about this? How about yak? And then zebra. Pretty sure that's it. And so, yeah, now it's gone through and it's done its thing. And it then marks everything off as ZZ and says, okay, these guys are done. They're now figured out. And the ones on the right are the new strings that I've sorted. And it's, again, it's kind of crazy to figure out some loops within loops. And we have to have these temporary counters to compare this against that and kind of resort our arrays and things like that. But again, the book will do its best to explain it to us. But it says, now run the program and use these words. It says, look at column 2. You see how the first name changes from Michael to Dylan to Alexa. Notice that what happens when Alexia is in the first column, Alexia becomes a ZZ. This illustrates how the program sorts the first and second word. So the first word, when we had these names here, Michael, Travis, whatever, it's kind of sorting them. So the first word somehow becomes, I can't follow this frickin' printout here. First word, this illustrates how the program sorts the first and second words. Travis, Dylan, Alexa, Susan. So Michael goes over here. These guys are over here. Then we go over here. And then we're doing some weird crap. And then we figure out, honestly, no, this is not helping me at all. So this little diagram here, not helping me. Sorry. So we're moving on. Here's how the program works. How about that? Let's get into the explanation, because this freaking chart here, I don't know, going crazy. Head exploded. Okay. So here's how the program works. And hopefully you guys will follow this. Hopefully it'll make some sense to you. But lines 50 and 60 sets the X value, the variable X. It says at the start, X is 1. Lines 1 through 10 compare A string X, Michael, with every other name in the array until the word it reached precedes Michael through Dylan. Then line 100 makes A string X equal to Dylan's place in the array, A string 3. When Dylan is compared to the fourth word, Alexa, A string X becomes A string 4. When all the words have been compared with one another, line 120 displays the first sorted word, Alexia. Line 130 changes Alexia's positions, A string 4 to ZZ or ZZ. At this point, line 50 and 60 make X equal to 1 again. A string X equals Michael is now compared with other names in the array to find a second sorted word. When Michael's place in the array becomes ZZ, line 60 sets X to 2. Then A string X, which is now Travis, is compared to all the names in the array to find out the next sorted word. When the array's values are all changed to ZZ, line 70 ends the program. Now, the next thing here it says to do is Do-It-Yourself Program 28-1, using the sort routine, change the program from the last chapter so that it alphabetizes your books by title, author, or subject. And I went back to the last chapter, and there was nothing about books at all. So I just did chapters 27's video like not even 2 days ago. So, and I went back and I looked in the PDF file of this book. It's not there. So I'm thinking when they did this, they're thinking of something else, but whatever they're thinking of, it's not there. And I think you get the point. But we're not done. I have a few bonus things to show you, but this was a pretty short chapter, and it says this chapter shows you a simple way to sort. If you need to sort many items, you may want to research faster sorting methods, such as a bubble sort, which is something that we're going to show you here in just a minute. So this was a program that was, I'm pretty sure this was 28-3. And I'm going to list it out here for just a second here, and I'm going to list through, let's just say list through 100 real quick. So let's look at the program. So we're going to clear the screen. We're going to dim 5 strings. We're going to input 5 different strings. We're going to clear the screen again. We're going to say x equals 0. We're going to increment x equals 1. We're going to say if x is greater than 5, then we're going to loop and say we're done. Actually, I could edit 70 and say if x is greater than 5, then print, quote, we're done, end quote, colon, end. All right, so let's list this through 100. So we dim 5, we input 5 strings. We clear the screen, we start x to 0, we increment x by 1 automatically. We say if x is greater than 5, then we're basically going to end. And now here's the first part of our logic. If a string x equals zz or zz, then we're going to go back to 60, and we're going to increment x to be 2, and then go back and increment x to be 3, and x to be 4, and then line 70 is going to say, well, once you're more than 5, we've sorted everything, so just stop. So this one here basically says once the code that comes after me does its job and replaces the text with ZZ, I'm going to go back here and then move to the next one and then resort and then move to the next one and resort and so on and so forth 5 times. Or I was going to say to infinity and beyond, but no, in this case here it's only 5 times. Now, in the middle of that we have a new counter, victory, V for victory. V is V plus 1. We don't necessarily have to start off by saying V equals 0 because by default all variables until defined automatically equals 0. So 85 by saying V equals V plus 1, because V was already 0, V just became 1. Now we have for Y equals 1 to 5, and this is where we're doing the sorting within. We're on A string 1, we have to count through all 5 strings and resort, right? So now we're saying if A string Y, which is A string 1, is less than A string X, and remember, we started off on X1, so A string X, if string 1 is less than the string I'm on, then X equals Y. And remember over here, X equals X plus 1. But if I was wherever Y is, if the string I'm on becomes less than that, then X equals that. So let's list 100 through. I'm trying to interpret their logic here. 100th, and then this is where we print at on the screen. Oh, this is where that V counter. So V equals V plus 1. This is just going down, right? So this is calculating halfway point, halfway across the screen, 32 columns down. Is going to keep skipping a line. So multiply that times V minus 1 and the A string X. So this is printing the string it's on and then doing its sorting and going through. This is just generating a pause because it actually does this pretty quickly. Then we go finish our Y. And then when we're done, wherever X is, we say that that string is ZZ. We're now go subbing 500. And now we're doing this thing on the left here, where on the left-hand side, we are printing all 5 strings, all 5 of the A strings that are being sorted in progress. So print at 0 plus 32 times I minus 1, A string I, 5 times. So the left-hand column is going to show us the names as they're being figured out. The right-hand column, which is being printed up here, is going to show us the names that it has sorted. So it's like we have like a left column is our work, our scratch pad. The right column is the ones that we've kind of crossed off and sorted. So that's what it's doing. But the thing I'm still not following is right here in line 100, the actual logic of how it's doing its sorting, but it's basically just doing a loop within a loop, saying if it's less than this, then it's, you know, and then kind of shuffling the arrays. So I'm oversimplifying it, but that's kind of what it does, right? So if we put in 5 names right now, so, and I put in like, okay, Robert and Henry and Steve and Alex and your mom. All right. So here's the name. So now you can kind of see it thinking as it's going through all 5. And now it's figured out the first name, and then it prints out in the left-hand column the sorting in process as it's scratching things off. And so Robert comes before Steve. Steve comes before your mom. So it put in everything alphabetical, and then now it should go through, and now it says we're done. I should actually change that line 70. Print at 128, comma, we're done, right? So we'll try that one more time. So we're just going to say Fred, Barney, Wilma, Betty, Better, Pebbles, right? So here's some of our Flintstones. So now it's figuring crap out. Who's the first guy? All right, we're thinking Barney's good, so we're going to scratch him off. He's a ZZ. Who's next? All right, Better or Betty, right? So B-E, then we got Fred. We got, who else is going to come after Fred? Is it going to be Wilma? Is it going to be Pebbles? Blah, 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 la, 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 la. All right, boom, we're done. So the 5 names have been crossed off and sorted. This is kind of like crossing them off after it sorts them. So I kind of get what it's doing visually, but I'm not quite sure I follow the whole thing mentally. So here, but I do in theory, but not specifically. So now let's look at 2 more programs that when I mentioned to Curtis I was going to be doing some sorting, and I was going to need to do some high score sorting. He gave me some sample code to use, and then I've kind of taken his code and done it to where I can do ascending or descending sorts, and I'll show you what Willis is talking about here right now. So these next 2 examples are courtesy of L. Curtis Boyle, and these are going to be sorting numbers and not text, but same principle. So let's look at the program. So first I say here, the line 0 says this is courtesy of L. Curtis Boyle. So now we're going to say NM equals 10, which is the number of entries to sort. I'm dimming a score into 10, so I'm dimming an array of 10, and this is where I feed in the scores. So I want to do first off, an ascending sort. So I'm feeding in numbers in a descending order. So I'm feeding in numbers from high to low to show you that I can sort them and actually print them out in the reverse order. And this logic, to me, is a little bit easier. So line 9, so line 8 and line 9 is basically me feeding some dummy numbers into the program. And then line 10 starts Curtis's code. So for counter equals 1, to NM minus 1. So since I'm doing 10, it's, so for counter equals from 1 to 9. And then for now, we're going to do a subcounter. So C equals counter plus 1 to maximum number. So if I start off on 1, if I'm going from 1 to 9, he's going to go from 2 to 10. So when I'm on number 1, I'm looking at value number 1, and then I'm inside that loop. I'm then looking at numbers 2 through 10. And now if the current number I have, in this case here, is greater than the number after me, then I'm going to plug them into a temporary number, which is where my counter is. And then I'm going to say this equals the one higher than me, plug that back in, and then swap the one out with the temporary one. So I'm going to keep looking one number ahead. If it's greater or less than, I'm going to swap the 2. And then go down to the next number, look one number ahead, and keep swapping, and kind of do it that way. So I kind of follow this one a little bit better. So the C within the CO, this is a counter, and this is a counter within a counter. So CO is the main counter and C is a smaller counter inside here. And then what I did in the end was I printed them out. So what I have, the couple of lines I added was basically showing you the numbers I read in, letting Curtis's routine do the sort. When it's done sorting, I then print them back out. So this is what an ascending sort looks like. So I read in numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then I print them out ascendingly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So this one, I think, is a heck of a lot easier to follow. It's smaller. I'm dealing with numbers. Numbers are easy to process visually and mentally, and we kind of get it. And I follow his routine pretty well, right? So I start on NM1, which happens to be 10, and then I say, okay, well now I'm going to go from 2 to 10. So now I'm going to be looking at 9, 8, 7, 6, 5, 4, 3, 2, 1. And then it says here, if 10 is greater than that, then I'm going to swap them. In this case, it is. So 10 is greater than 9, so I'm going to swap those two. Then I'm going to go through the rest. Is it greater than, and then what happens is that 10 will just kind of go all the way to the end. Then it's going to get to the next one, then it's going to compare that, and then 9 will get bumped to the end, and then 8 gets bumped to the end, and it just kind of keeps doing that. And so I kind of see what it's doing there. So this is a ascending sort. It takes numbers and shows them from smallest to largest. And so I can do the exact opposite now by changing the greater than to a less than. And this one I figured out all by myself. I took Curtis's code and I just reversed the symbol. So now instead of it being a greater than, now it's a less than. And then so I just modified that to my final demonstration that I'll show you here. 28-5, bonus content not in the book. This is the deluxe edition of this chapter, boys and girls. And what we'll see here is I load in numbers from low to high, and then it sorts them descendingly, and it shows them to me from high to low. And this is kind of what I want for a high score table, right? Where I want the highest score to be the first number on the list and do it that way. And then, kind of, so the 1,000, you got 1,000,000 points, that's going to be if that's the highest score, that's the top of the list. If you got 900,000, you're the next one, so on and so forth, right? So I fed in numbers sequentially from low to high. I did a descending sort, which sorts them from high to low. And so the only thing I changed here was number one, the data set that I fed in is sequential and ascending. I read in my data, I printed it out to show you what the numbers were. And then this is Curtis routine here, basically 10, 20, 30, 40, and 50. This is the whole little program Curtis gave me. It's very small, it's very short, it's very sweet, it gets the job done. In this case here, I just changed greater than to less than. So, at this whole time I'm moving my mouse on my screen, but you guys weren't seeing my mouse. I'm an idiot. Okay, I saw the mouse, but it's not, that mouse wasn't being recorded. Now that I have the mouse on the other screen, you can actually see it. Anyways, pretend like you knew what I was pointing at before, because I'm not recording the scrap over again. You're big boys, you can figure it out. So anyways, yeah, so I just changed that to that, and there we have it, and it does its little thing, and then I print it out. So I understand this well enough, and for my needs, I am going to use the Curtis routine to help me sort my scores. I'm going to have names go with the scores too. So as I'm doing this, I'll be not only shuffling the numeric array, but I'll be shuffling the text array too. But I hope this has made a little bit of sense to all of you. And just to refresh it all, we're going to just load our first program again, which I don't remember what the hell it was, but the first one was type in 2 words, right? So Apple PC, right? So Apple comes before PC. Ooh, I'm sure there are some certain people who would like to think that. But yeah, so you kind of get the idea here. We can use basic to do greater than and less than. In our first example, we were really just comparing two things, but you can get a little bit fancier, load in an array of information that could be in any random set of data, any random set of names, any random set of numbers. Use this same comparative logic and just create a loop to compare within the list and do some sorting by just, is it greater than or less than? If it is, we'll flip them around and we'll keep going, rinse, lather, repeat till we get to the end. That's kind of what it means. I know this one, for me, I'm struggling with this a little bit because I understand it but I don't feel like I'm totally owning the logic that the chapter has used, because it's not my logic. I think what I'm going to need to do at some point in time is do this on my own and write my own program, beat my head against the wall a few times to do it from scratch and make it work my own way, which may or may not be as efficient. But once I've gone through that struggle, I think I'll understand it better and appreciate it a little bit more. But hopefully this has been of some benefit to some of you. But what I am trying to do is to continue my hashtag commitment Coco and do as much Coco content as I can for the short term and hopefully for the long term. So now it is the 19th. I created a chapter. It's only been 2 days now. I'm creating another chapter. Who knows? I might get fancy and do a third chapter, maybe even tonight. But this is 2 basic chapters in 2 or 3 days, which is a much quicker pace than I've done the past 9 months prior to this. So look forward to more Coco content from me, my commitment to the community, more Coco content. Hope you enjoyed this video. Make sure you like and subscribe my new Color Computer channel as well as my Original Gamer channel where all my stuff started. Make sure you check out imacoconut.com for all things Tandy and Color Computer. If you want to hear about the Coco on a weekly basis, and you can go to cocotalk.live. This is the website that points to our weekly live talk show, which you can also hear replays of. You can watch it on YouTube. You can listen to it as a podcast. You can watch it as a podcast. There's lots of ways to experience Coco Talk, and lots of good stuff has been going on Coco Talk this past year, which we hope you enjoy, and we're looking forward to creating more Coco Talk goodness for you. So thank you all for watching. OG Stevie Stroh saying, peace out. Coco forever. Hashtag commitment Coco. Bye-bye, everybody.